Right, welcome back again. Now we're going to look at situations where we have our future principal who is excited to be a patriot. We're going to look at situations where we are solving these equations by graphing and they are giving us one root as an answer. Now, think about what a parabola looks like. And there's really only one way that a parabola can have only one point of contact with the x-axis, all right? And so I just think about that as we're doing this, and I think you're going to see it once we go through it. So remember, a root is a solution to the equation once y is 0, and it winds up being the x-intercept. So it's where it crosses that x-axis. All right, so we're going to do these problems the same way we did before, where we give you these equations, we write it in standard form, you set it equal to 0 first, and then you make that 0 into an x. So let's kind of do that. I'm gonna break this one down a little bit just in case the last way we did it was a little slow. So the very first thing we're going to do is we're going to move everything over to one side. So we're going to move everything over to the side that the x squared is on. So we've got x squared plus 25, and then we're going to move this 10x over to the other side by subtracting 10x from both sides, right? So we're going to go minus 10x, and when I subtract it from this side, that makes it equal to 0. So that's my first equation. All right, that's my first step in this. Now my next step is I have to write this I have to write it in y equals ax squared plus bx plus c form. All right, so you might be looking at this saying, well, where is he getting this y from? Well, the y is going to replace your 0, because this 0 is just one case where y is equal to 0, and then what are your roots as a result of it when y is equal to 0. And that's kind of what we're after to find. But we want to be able to do this by graphing the entire parabola. So in order to do that, we got to know what other values of y are so we can get a sense of how to graph this. So in that case, we do need a y in here. And so what you'll do is we're going to replace our 0 when we get to it with a y. And then the other thing we're going to do is we're going to write this in the ax squared plus bx plus c form. So I'm going to swap that negative 10x and 25, and then I'm going to make this equal to y. And so then once I have this, if you're picky about it, then you might say to yourself, okay, well, this has to look exactly how it looks, so you make your y in front this time. It doesn't really change the meaning of it, it just looks a little more familiar. So this form right here is what we are dealing with, and this is what we want to graph. So then we go to decimals, all right? And the first thing I'm going to do is I'm going to get rid of this stuff. And then I'm going to put in y is equal to x squared, I believe it was minus 10x plus 25. Let me look and make sure, but I'm pretty sure that's it. That's it. All right, so x squared minus 10x plus 25. Now, hopefully you were thinking when I said, what is the only way this can have one root? Well, the only way it can have a root is if it actually sits on the line. It only meets the line at one point, and later on in geometry, you'll know that that point is called a tangent. All right, but right now you don't need to worry about that. So it meets at just this one point, and that point also happens to be, think about what that's called. That's called the vertex, right? So your vertex is actually your solution to this. It's your root, right? And it's only one, right? It's only one point. So later on, you're going to see that this is actually a double root when you factor these equations and you start setting them equal to 0, because you'll get two factors that are exactly the same. Meaning you still get two roots, but they yield the same number. So that's why it's called a double root. But like I said, don't worry too much about that now. You can think of it as one distinct solution while I continue to swirl around that and you guys wonder what's wrong with me. All right, so let's do another one. solve this equation by graphing. All right, I'm going to get rid of some of this room up here. I don't know what's going on, what I was doing, I think because I was creating. All right, so we're going to take this, all right, we now know we have to write it in standard form, so I'm not going to leave that there. We're going to pull up our equation editor here. And we're going to start by writing y, because we know y is going to be one side of it. And then we're going to have our x squared, all right? And then it looks like the negative 8x is on the same side as the x squared, so the sign will stay the same. And then this negative 16 is over here. It needs to go over here with everything else. So that means it's going to be positive, all right? X squared minus 8x plus 16. So that is the equation we are going to use. We have it set equal to y, not equal to 0. We want it equal to y. And so next we go to Desmos. And we go y is equal to x squared minus 8x plus 16. And again, you get the same kind of situation. Right? You have a situation where there's one root, okay, because it's sitting right on top of that, okay, and there's ways where you could change this, okay, and because like look what would happen if I change this sign, right? Right? Then the root's changed and it moves it over, okay. But what you'll notice with all of these that have one root is their square trinomials. If you remember that term, they're perfect square trinomials. All right, so that's going to be kind of helpful later on when we're factoring and coming up with solutions for these. So hope this is making some sense for you, and that these visualizations on Desmos are actually helpful.